All right, so if you can't visualize the problem, just draw a picture of what's going on here. So we want to land a plane on a runway. So here's our runway. And our runway is 1 kilometer long. 1 kilometer. And what am I going to need to do with that right away? What's wrong with 1 kilometer? First, convert it. Anytime you have to convert, do that first so you don't forget it. So that's just 1,000 meters. The other thing is we're going to stop with 1/4 of the runway left. So how much margin do we have to stop the plane? What's the distance that we're going to stop the plane? 750 meters. So that's probably more important. So we're going to start our problem over here, right at the beginning of the runway. And we're going to finish our problem at the stopping point, which is 750 meters away. I'm going to run out of room. And we want to know the acceleration. We want to know the acceleration? Yes, we want to find out what the acceleration is. So we're trying to find an equation that relates what? Oh, do we care about time? Do we care about acceleration, final velocity, initial velocity, what? We obviously care about acceleration, but how are we relating it? Time, distance, velocity? Distance and velocity. So we look for an equation, or we kind of try to think of an equation, hopefully, that relates the acceleration to a change in position and a velocity. There's going to be two choices, and you might try both, but one of them is going to be better than the other. Which one do you want to try? The third one, the squares, right? So let's give it a shot. And it may not work out, and this is something that with practice you'll learn. So Vf squared equals Vi squared plus 2a change in position. And we want to solve this equation for acceleration. So rewrite the equation, Vf squared minus Vi squared. And we'll just take the extra step just for practice. Divide by 2 delta x. So Vf squared minus Vi squared divided by 2 delta x equals our acceleration. Are there any values that we can just throw away now because they're 0 or they don't matter? Vf. Vf is going to be 0 because we're going to want to stop. Let's take that out right away, and that'll be a useful thing. Now we plug in our values. Vi, 130 meters per second, quantity squared, negative, divided by 2, and our change in position, 750. Our change in position is from where we started to where we finished, 750 meters. That's going to be equal to A. And I don't know what that is squared. 16,900. Negative 16,900. And meters squared over seconds squared divided by 1,500 meters. Get rid of a couple of zeros. Is 15 going to 169? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.6. So acceleration is equal to negative 10.6, and my units, meters per second squared. Barely got it. So negative 10.6 meters per second squared required in order for us to stop that plane in this at distance.